Imagine living on a planet where your morning coffee is brewed in a giant floating balloon high above clouds of acid. Welcome to Venus, the ultimate extreme getaway. Today we're diving into one of the wildest ideas out there, colonizing Venus. Yes, you heard me right. Venus, the scorching, pressure-packed, acid-sprinkled sister of Earth. While most of us think of Venus as a giant, uninhabitable furnace, what if we could make it home? Buckle up because we're about to explore the top 5 challenges of colonizing Venus and, along the way, check out some realistic solutions with our current tech, and a few delightfully out there ideas that belong in the sci-fi realm. First up, Venus's extreme surface conditions. Picture this. The surface temperature on Venus averages around 460 degrees Celsius, which is hot enough to melt lead, and the pressure is roughly 92 times that of Earth's sea level. No ordinary day at the beach, right? Now, if you're in the mood for a sci-fi blockbuster, imagine building full-scale colonies on the surface with ultra-thick futuristic shields that can withstand the heat and pressure. Or better yet, what if we could terraform Venus itself? After all, this is a popular idea with Mars, and cooling its surface down to Earth-like conditions. Now, tempting as it sounds, this idea is way beyond our current engineering and material science capabilities, and it's firmly in the realm of science fiction. With our tech today, one of the smartest and actually craziest sounding moves would be to leave the ground and all its searing heat and crushing pressure behind. Instead, we could build floating habitats high in the Venusian atmosphere around 50 kilometers up. At these altitudes, conditions are surprisingly Earth-like. Think of it like creating a giant buoyant bubble in the sky where temperatures and pressures are much more manageable. We'd use aerostats filled with helium or hydrogen and design these structures with heat-resistant materials that are already on our radar from space exploration research. Next challenge, the corrosive, acid-filled atmosphere. Venus's clouds are loaded with sulfuric acid and other nasty chemicals that would have our equipment melting faster than ice cream on a hot day. For our wild imaginations, picture smart self-healing materials that not only repair themselves but also actively neutralize the acid around them. This material could even be biological, like some type of plant that feeds off of acid. It's a neat idea and would be a game changer, but alas, this technology and biology remains in the science fiction drawer for now. We're not there yet, folks. But with today's technology, we can take advantage of advanced acid-resistant materials. By using specialized alloys, Teflon coatings, and ceramics, we can build structures designed to endure Venus's acidic environment. We design these habitats to minimize the time any component spends directly in the corrosive atmosphere and set up maintenance schedules to regularly replace or repair parts, kind of like giving your spaceship a spa day every now and then. Now, let's talk about life support and resources. Venus isn't exactly a cornucopia of fresh water or fertile soil. We'd have to come up with ways to support life in an environment where water is scarce and food is a challenge. You might dream of terraforming Venus with open-air Venusian agriculture, vast fields of crops growing under a swirling acidic sky. While the idea of a Venusian farmer might be hilarious to picture, growing food on a planet with such hostile conditions is just not feasible with our current technology, obviously. It's a fun thought experiment, but one that's better suited for a futuristic novel. Now, the answer lies in a closed-loop life support system, the same kind of systems used in the International Space Station. These systems recycle water, air, and nutrients, ensuring that every drop counts. Additionally, we can explore in situ resource utilization, ISRU, which means tapping into the resources available in Venus's atmosphere. Imagine extracting trace amounts of water or oxygen right from the air. Every little bit helps when you're living in one of the harshest places in the solar system. Our fourth challenge deals with the dynamic environment and gravity on Venus. Although the gravity on Venus is close to Earth's, about 0.9 Gs, the planet's atmosphere moves at a breakneck speed in a phenomenon known as atmospheric superrotation. This means unpredictable, high-speed winds that can make life in a floating habitat a bit like riding a roller coaster. One seemingly logical but slightly unrealistic idea would be to build enormous fixed structures that anchor directly to the Venusian surface, defying the winds altogether. As explained earlier, we wouldn't survive the surface temperatures long enough to be able to construct anything of that size or magnitude to the ground. And we can't build anything that high on Earth today. So realistically, to tackle these wild winds, our floating habitats would need active stabilization systems, and we're talking small thrusters, control surfaces, or even aerodynamic shaping that can keep the habitats steady. Imagine a giant airship with built-in stabilization, ensuring it stays right where it needs to be, even in the midst of those fast-moving atmospheric currents. We might also use tethering systems to anchor our platforms, drawing on aerospace techniques we already use on Earth. Finally, we have the challenge of transportation and logistics, sending supplies and people to Venus. The energy requirements and technical hurdles of interplanetary travel are enormous. There's a tantalizing world of advanced propulsion breakthroughs, think warp drives or space elevators, or like a video we made previously, dark energy propulsion, that could whisk us to Venus in record time. Now, while these ideas are popular in science fiction and make for great movie plots, they're not currently feasible with our understanding of physics and available technology. They remain a distant dream, one that might someday revolutionize space travel, but isn't in our toolbox quite yet. For now, the best approach is incremental missions using conventional propulsion methods, chemical rockets, and perhaps in the near future, nuclear thermal propulsion are our go-to options. We've already got the basics down from missions to Mars and Venus, like using aerobraking to adjust orbits. It's all about building on what we already know and gradually developing more efficient methods to get us to Venus safely and regularly. So, there you have it, folks, the wild, wacky, and wonderful, challenging reality of colonizing Venus. We've seen that while the idea is daunting, especially with its extreme surface conditions, corrosive atmosphere, and logistical nightmares, there are seemingly realistic steps we could take with today's technology. Floating habitats in the upper atmosphere, advanced acid-resistant materials, closed-loop life support systems, active stabilization, and incremental interplanetary missions are all within the realm of possibility. On the other hand, our unrealistic solutions, some of which might work better on Mars, like terraforming the planet, self-healing materials that neutralize acid, Venusian open-air farming, gravity manipulation, warp drives, these are all firmly in the realm of science fiction, but hey, dreaming big is what pushes us to explore, innovate, and sometimes even change the course of history. Colonizing Venus isn't just a wild thought experiment. It's a challenge that stretches our engineering, scientific, and imaginative limits. Even if we never set foot on the Venusian surface, exploring these ideas can lead to breakthroughs that benefit space exploration as a whole. Plus, it's a reminder that sometimes the most inhospitable places hold the promise of discovery if we're willing to push the boundaries of what's possible. If you enjoy this journey through the challenges and possibilities of Venus colonization, make sure to hit that like button, subscribe to Astronomy Revelations, and drop a comment below with your wild ideas for life on Venus or other planets. Who knows? Your idea might be the next big breakthrough in making humanity an interplanetary species.